Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5, Continuity and Differentiability in Exercise 5.1, 34th sum. Already in the last videos, I have uploaded solutions till 33 sums, so please do check it. Now let's start with the 34th sum. Find all the points of discontinuity of f defined by f of x equal to modulus of x minus modulus of x plus 1. So here they're asking us to find out the discontinuity points for the given f of x. So here you can notice that f of x is in the form of two functions. Okay, so modulus of x is a one function, the other function is modulus of x plus 1. The both are in the difference form. So instead of finding f of x together, partially we are going to see the discontinuity. Okay, so first we are going to take modulus x, and we are going to see any discontinuity points are there in the real line. Now same by modulus of x plus 1 we are going to do. If there is no discontinuity point, then we can say that difference of the two continuous functions are still continuous. So that means there is no discontinuity points in the real line. So we can end the conclusion in that way. Okay. So now let's see. First f of x, no. F of x is given. F of x equal to modulus of x minus modulus of x plus 1. Okay. Now I'm going to take g of x as a modulus of x, and I'm going to check discontinuity point for g of x separately now. So since it's a modulus function, we have to redefine that. Now minus x and x. So this has to be used if x is less than 0 and this one x is greater than or equal to 0. Now using the if condition, we have to break the real line. If we break the real line, no, we can see the two intervals. So here and one point. So we are going to test the continuity by part. Okay, at x equal to 0, first we are going to see the continuity of the g of x. Okay, to check the continuity, we need f of 0, left hand limit of the 0 and right hand limit of the 0. If all the three values are coincide, then we can say that g of x is continuous. Now if x is less than 0, we are going to check the continuity. If x is less than 0 means we have infinity real values lies in this interval. So we can have a common name like let's see be the any real value. Okay, which is less than 0. Then same way, to check the continuity at x equal to 0, we had a three things, no, f of 0, left hand limit, right hand limit. Same way here, f of c, left hand limit and right hand limit is required. If all the three values are coincide, then we can say at x equal to c, the function is continuous. Okay, the g of x is continuous. So similarly, if x is greater than 0, we are going to check it. Okay, so that means we can able to cover the entire real line, no. So x less than 0, at x equal to 0, x greater than 0. So we were able to check throughout the real line. Okay, now let's say any order is fine. I'm going to take this order at x equal to 0 first. So case 1, at x equal to 0. Okay, when x takes exactly 0, we need g of 0, no. Here function in terms of g, no, g of x. So g of 0 is required. So g of 0, if x takes the exactly 0, second function g of x equal to x, then g of 0 will be 0. Now left hand limit x is approaching to 0 from the left hand side. Okay, left side close values of 0 are approximately 0, but those values are less than 0, smaller than 0, right? Then what is the suitable function here? Minus x. Now applying the limit, what happens? Minus 0, which is 0 only. Now right hand limit. Now limit x is approaching to 0 from the right side g of x. Right side close values of 0 are approximately 0, but they are those values are greater than 0. So that means suitable function is what? Second function. Now applying in place of g of x as a x. Now applying the limit, what happens? 0. Now what we can conclude from these results? G of 0, left hand limit, right hand limit is equal. So we can say that g of x, that is modulus of x, is continuous. Modulus of x is continuous for, okay, continuous at x equal to 0. Okay, now as of now we tested only at x equal to 0. Now we are going to check in this interval, that is if x is less than 0. So case 2. Case 2, if x is less than 0. Okay, if x is less than 0, we have infinite real values. Let C be any real value, at the same time C should be less than 0. So we are taking C some in this particular interval. Okay, it can be any value in this interval and C is less than 0. So we need to find out G of C first. So suitable value is what? For G of x has a minus and x. Okay, C is less than 0. If it is less than 0, minus x is the suitable function. So G of x equal to minus x, then G of C will be minus C. Now let's talk about left hand limit and right hand limit here. Left side closed values of the C and right side closed values of the C are both are less than 0. If it is less than 0, we have only one function, right? So instead of finding left hand limit separately, right hand limit separately, we can combine it and we can find out together. Now limit x is approaching to the C from both the sides, g of x. So g of x is, here x C is what? C is less than 0. Suitable function is minus x. Now applying the limit minus c only we will get. Since the function is same, in the left hand side, right side, we are going to substitute in place of g of x as a minus x. Then result will be the same. So instead of finding like this separately, I combinedly I found here. Okay, so now here you can notice the result g of c and limit x is approaching to c, g of x both are same. So what we can conclude from this, g of x equal to modulus of x no is continuous if x is less than 0. Okay, so next we are going to see for greater than 0. If x is greater than 0. Okay, so if greater than 0 means we have checking at this particular interval, right? So in this interval we have infinite real values, we can have a common name as a C. So let C be the any real value, at the same time C should be greater than 0. Okay, now first we need G of C. So what is a suitable function? C is greater than 0. If it is greater than 0, what is the exact function here? X, no, suitable function is x. So G of x equal to x, then G of C will be C. Now left side closed values of the C and right side closed values of C both are greater than 0. So if it is greater than 0, left hand limit, right hand limit individually, it's not necessary to write it separately. Okay, it's a waste of time. So together we can find out limit x is approaching to the C, g of x. So g of x is only the x, substituting the suitable one. Now applying the limit c. So here we have g of c equal to limit x is approaching to c, g of x both are same. So from the case 3 result we can say that g of x equal to modulus of x is continuous if x is greater than 0. Now from above all three cases, no, from all three cases, what is our observation? We can say modulus of x is continuous for all the real values. Okay, now similarly, the second term of the given function. What is the second term of the given function? That is modulus of x plus 1. So modulus of x plus 1, separately we are going to check the discontinuity. Okay, so at what point its function is getting discontinued, that we will check it. Okay, so I'm going to name it as a h of x as a modulus of x plus 1. Let h of x equal to modulus of x plus 1. Okay, so as usual, so here what we done, if the modulus function is given, we have redefined, no, the same way modulus of x plus 1 also we need to redefine it. Okay, so first let's redefine this h of x equal to, on redefining you will have negative of x plus 1 and positive of x plus 1. So the first one we have to use if x is less than, plus 1 taking to the other side, minus 1, no, so minus 1 if x is greater than or equal to minus 1. Okay, now using the if condition we have to break the real line at minus 1. Okay, so now This interval is what? If x is less than minus 1, and here if x is exactly minus 1, and here if x is greater than minus 1. So by part we are going to check the point of discontinue is there or not. Okay, so first I am going to take this as a case 1 at x equal to exactly minus 1. So case 1 at x equal to exactly minus 1. So that means h of minus 1. So to check the continuity for anything, we need three things, no? That is h of minus 1, left hand limit, right hand limit. All the three things are required. If the three values coincide, we can say the function is continuous at x equal to minus 1. So at x equal to minus 1, the function is not getting discontinuous. Okay, so let's see. So h of minus 1. So if x takes the exactly minus 1, suitable function is the second one, no? Then applying the applying the value h of x equal to x plus 1, less x equal to exactly 1, second one. So applying the value, what happened? Minus 1 plus 1, which is 0. Now, left hand side closed values are less than minus 1. If it is less than minus 1, we need to use the first function. And right side closed values of the minus 1 are greater than minus 1. We have to use the second function. Since for the left hand limit, right hand limit, different functions, we need to work out separately only here. So now left hand limit. Limit x is approaching to the minus 1 from the left side, h of x. So what is the suitable h of x here? Left side closed values are approximately minus 1 but less than minus 1. That means first function. Now applying the limit, what happens? Minus of minus 1 plus 1. Minus 1 plus 1, 0. Okay, left hand limit result is 0. Now right hand limit. Now limit x is approaching to minus 1 from the right side, h of x. So what is the h of x here? H of x is suitable function is x plus 1, because right side closed values of the minus 1 are greater than minus 1. So limit x is approaching to minus 1 from the right side, h of x is x plus 1. Now applying the limit minus 1 plus 1, which is 0. So now from this result, what we can say? H of minus 1, left hand limit, right hand limit are equal. Then we can say that h of x equal to modulus of x plus 1 is continuous at x equal to minus 1. Okay, it is continuous. Now in case 2, we are going to check it in this interval. Okay, x is less than minus 1. Case 2, if x is less than minus 1. Okay, if x is less than minus 1, we have infinite real values lies in that particular range. Okay, so now let c be the any common name we can have. Let c be any real value, at the same time c should be less than minus 1. Okay, so to check the continuity, we need like h of c, then left hand limit, right hand limit is required, no? So first h of c, let's find out. So c is less than minus 1, suitable one is what? H of c equal to minus of c plus 1. So h of c will be minus of c plus 1. Okay, now let's talk about left hand limit, right hand limit. So basically we have taken C from this interval, right? So left side closed values of the C are, as well as right side closed values of the C are less than minus 1. If it is less than minus 1, we have only one function, right? So for the left hand limit also, in place of h of x, minus of x plus 1 only we are going to substitute. Similarly for the right hand limit. So since it's the same function, result is going to be same. So instead of finding it left hand limit, right hand limit separately, we can find it together. So limit x is approaching to c from both the sides. Okay, both together, h of x. So suitable function is the first function, that is minus of x plus 1. Now applying the limit minus of c plus 1. Now you can notice that h of x result and limit x is approaching to the c, h of x both are same. So what we can say from this, h of x equal to modulus of x plus 1 is continuous if x is less than minus 1. Okay, next in case 3, we are going to test if x is greater than minus 1. So case 3, if x is greater than minus 1. If x is greater than minus 1, no. We have infinite real values lies in this particular interval. So we can have like some common variable that c can be any real value. Okay, so let c be the any real value. Any real value at the same time c should be greater than minus 1. Okay, it can be anything, but at the same time it should be greater than minus 1. So greater than minus 1 means what is the to check the continuity, three things are required: h of c, left hand limit, and right hand limit is required. Now what is the h of c? C is a greater than minus 1. So what is the suitable function here? Suitable function, if it is greater than minus 1, x plus 1. So h of x equal to x plus 1, then h of c, in place of x as a c, if you replace c plus 1. Okay, now for the c, left side closed values and right side closed values are greater than minus 1. That means for greater than minus 1 we have only the single function. So for left hand limit, in place of h of x also we are going to replace x plus 1 only in place of function. Similarly for the right hand limit also. So instead of finding left hand limit, right hand limit separately, together we are going to find out. Now limit x is approaching to the c, okay, h of x. So suitable function is what? X plus 1, replacing h of x as a x plus 1. Now applying the limit, we will be getting c plus 1. Now what we can say from these two results? H of c equal to limit x is approaching to the c, h of x. So we can say that h of x is a continuous if x is greater than minus 1. Now we had three cases for the second term as well. So what are those? So here at case 1 is at x is exactly minus 1, function is continuous. Okay, if x is less than minus 1 also function is continuous. If x is greater than minus 1 also function is continuous. From all the three cases we can say that the function is continuous throughout the real line. Okay, so from all three cases h of x, that is modulus of x plus 1, is continuous for all real values. That means there is no point for the discontinue for all real values. So already for the first part, that is g of x, also we told modulus of x is same continuous for all real values we told. Now in continuity we have a property uh, to difference. Okay, so difference of continuous function is also continuous. Okay, so we know that difference of two continuous function is also continuous. So that means modulus of x plus 1 is continuous, and modulus of x is continuous. The difference is also continuous. There is no point of discontinuity. Okay, so that means f of x is continuous for all the real values. What is the name in the question? It's given, it is f of x. No, continuous for all real values. So that means there is no point of the discontinuity. Okay, so that's all the solution for this sum. Thank you for watching, and please do subscribe. Thank you.